Hello, and welcome back to another episode of the LNG Industry Podcast. Joining me today is Jan Emblemsvåg, Professor at the Norwegian University of Science and Technology. Jan has served in senior management positions in the industry, including Yard Director for Vard Serviknes, Senior Vice President of Ship Design and Systems at Rolls-Royce Marine, and General Manager at Mead Sundbruk, designing and manufacturing advanced pressure vessels. Today, he is Professor at the NTNU, board member, consultant, author, and speaker. His areas of expertise include operations management, cost management, life cycle analysis, and renewable energy, including nuclear energy. Over the last 5 years, his nuclear propulsion research has dominated his calendar. He typically takes a techno-economic environmental view to develop solutions to challenges at hand, partly due to his industry background, but also as a result of his research and PhD topic. He has written several books and several dozens of internationally published journal papers, and holds a PhD and MSc at the Georgia Institute of Technology in Mechanical Engineering and an MSc at NTNU in Mechanical Engineering. In this episode, we're going to be talking about developments in nuclear propulsion for the shipping industry, what's changed since its introduction 80 years ago, what the future looks like, and how it might be adopted for use in LNG carriers.
LNG Industry serves as the go-to hub for all those following the latest developments in the LNG sector, providing spotlight interviews, in-depth articles, and regional report. LNG Industry covers the global marketplace. Register to receive a print or digital copy at lngindustry.com.
So hello, Jan. It's great to have you on the podcast today.
Yeah, thank you for having me, and I'm looking forward to the questions.
So let's start by looking at the journey nuclear propulsion has had over the last few decades. In your view, what progressions or changes have there been with nuclear propulsion since the first nuclear-powered vessel entered operation in the 1960s?
Yes, the first nuclear-powered vessels, they were using so-called Generation 2 reactors, light water reactors. Generation 2 light water reactors had a number of issues and would today not be most likely allowed in civilian nuclear shipping. A lot has happened since then, and I would say it's a couple of things that have happened. One is that we have now started a serious journey on developing Generation 4 reactors that have many advantages over the light water reactors. And also number two is that there is a genuine desire in the industry and in maritime industry and in society at large to actually develop and come up with a new solution to the current fossil fueled propulsion systems. Of course, partly due to environmental concerns, but we also see that the situation in the Hormuz today with the volatility of the fuel prices is not an advantage, of course.
And are there any new barriers that have materialized in more recent times that are perhaps prohibiting the wider use or availability of nuclear-powered ships?
I would say it's almost the reverse. Barriers has been removed. So, for example, one of the key things is TRISO fuel, which is let's call it a nuclear ceramic fuel that has a lot of very superior qualities in terms of proliferation resistance, but also if a ship goes sink, essentially, it will not lead to any environmental harms because the TRISO fuel can keep the radioactive isotopes within the fuel for hundreds of thousands of years. This wasn't available in the 70s and 60s. And another thing is that with Generation 4 reactors, you then end up building safety not only on the reactor type, safer reactors, but you also have a accident-safe fuel. So the total system safety has radically improved.
Okay, and moving on to nuclear as a technology a bit more, you mentioned a couple, but what are the different types of nuclear propulsion available on the market, and what's the most common or effective?
Right now, the only common available in the market is the classic pressurized water reactors that the nuclear navies of the world use. The technologies that we work on, there are three reactor types that we're looking at. It's gas-cooled reactors, it's with TRISO fuel, molten salt reactors with TRISO fuel, and lead-cooled reactors with uranium nitrate. These three are not commercially available, but they are not very far from being available. We think that based on the work that these companies are doing today, that it's realistic to hope for the first nuclear-powered ships in the early 2030s.
You briefly touched upon it earlier, but something that's obviously often discussed when talking about nuclear is safety. So how safe is nuclear propulsion for commercial use in the shipping industry, and are there maybe any sectors that it's more or less suitable for?
Yes, the safety of these Generation 4 reactors is now based on what we call passive safety, which means that typically gravity systems or other forces of nature that regulate their performance, unlike the old Generation 2 reactors that have to be actively managed by people or systems. So by introducing passive safety, the safety performance therefore radically improves. And it's really hard to see if they really can fail at all. But if they did fail for whatever reason, say a collision or something like that, then comes, of course, the superior fuel on top. So there are multiple barriers of safety now available, unlike the old nuclear power ships of the 60s and 70s.
Okay, and aside from this, what are some of the other advantages of using nuclear propulsion for the shipping industry?
Well, one of the more obvious one is that we can return to design speed. So today, a lot of ships are slow steaming, typically lumping around at 10, 11, 12 knots. From a design perspective, could have made, twice the speed. Returning to design speed will add a lot of revenue for these ships. We done some simple calculations, and you could, for example, for an LNG carrier, you could easily add 40% more revenues simply by going faster. Of course, assuming that there is a market for it, of course. And we therefore believe that in the longer term, these ships will outcompete the heavy fuel oil or the fossil ships, because not only do they go faster, but they can also go much longer without refueling. We have in our work set the target of 5 years or longer on a refueling interval. And those 3 reactor technologies that we work on can all do more than 5 years. And that means essentially for a ship that once it's being classed and approved, it can go for 5 years until next classing and approving. When you take the added speed advantage into account, this also includes, of course, a much better capital efficiency. You can do more trades faster, cheaper.
And obviously, our focus is the LNG industry. So how might nuclear propulsion affect or aid LNG carriers?
What's really good about the LNG carrier segment is that it's capital-intensive ships as of today, and they operate between one industrial site to another industrial site. And this is very ideal place to start with the new nuclear propulsion systems. For each and individual ship, added speed would be a great advantage. Also, delivering the entire cargo, meaning that you don't use boil off, will be another advantage. The challenge, of course, with the LNG tanker segment is that, for example, if you do trade from US to Europe, you have very low alternative cost on the LNG on the US side, which makes it hard to compete for the nuclear propulsion solution. But that's a good starting point, because if we want this to succeed, it has to make sense economically. We expect that the first 10 ships will probably not be economically viable compared to today's LNG carriers. But once we pass number 10, certainly number 20, 30, they will actually outcompete today's LNG carriers on cost and time and delivery and the whole thing.
Okay, so it sounds like there's some good prospects for LNG carriers then. Perfect.
Absolutely.
And then presumably, like with any other fuel, ports and terminals will require appropriate infrastructure to handle nuclear-powered ships. Are there any specific requirements or restrictions that ports may have in relation to this? And will it perhaps vary depending on regions? You mentioned the US and Europe. Will there be any differentiation between those?
There will most likely be some slightly different versions of the rules. But I have been talking to a number of ports, and they actually look at this as a big advantage. Because what they will do is to get rid of their fuel storages that they have today. And these large fossil fuel storages represent a significant risk to these ports. By eliminating those fuel storages, the total risk for the port is actually much less. When it comes to the individual ships and access and so on, this is something we have to work out in details. But we actually, the Norwegian Nuclear Regulatory, GSA, has actually a lot of experience with port access for naval ships. We don't really see any big problems here at all. There are, of course, some rules and adjustments that has to be made, but in the end, I think this will be a major step forward for the ports, actually, and not a problem. And let me also emphasize that this is one of the reasons we have chosen Generation 4 reactors with very low pressure. Because when you have very low pressure and passive safety, these ships have a very small safety emergency zone around them. Actually, it's just the enclosure in the ship, which means that the ships will not need to stay clear of each other in any particular way because they're nuclear. In many ways, I think for ports, they will be quite similar to fossil ships when it comes to distances and handling and all these things. Maybe some access by people has to be restricted, maybe, but we'll see. This is work still under process.
Mm-hmm. And for other alternative fuels, there are guidelines in place, such as the IMO and FuelEU Maritime. What international or regional regulations and policies might be needed to support the wider use of nuclear propulsion for the shipping industry?
Yeah, so now the IMO is looking at updating the 1982 convention, which wasn't ratified, and make it technology neutral. Back then it was tailored to light water reactors. Before there is a convention that we can use, our plan is actually to follow more the analogy of the aviation industry. So what we would like to do is to set up nuclear corridors between ports and countries. And these nuclear corridors will be supported by MOUs between the governments involved and the ports involved. And based on that, these ships will be able to operate within those confined operational areas. This will, of course, be a drawback in the beginning, obviously, but this is what they do in the aviation industry. When you have an international airport, it's not like the guys on the airport decided that, well, why not send airplanes abroad too? No, there's a lot of regulations behind bilateral agreements that regulate insurance and all kind of stuff. And this is essentially what we plan to do until there is a convention or protocol on a global scale that we can follow. For example, IMO or somebody like that. Yeah.
And do you think the regulations will vary depending on the sector? For example, will they differ between LNG carriers, container shipping, icebreakers, or will it be more industry-wide?
Very, very good question. I think, given the criteria we have used in selecting the technologies, I don't really see any need for having market segment-specific regulations. There might be need for reactor-type regulations, but maybe not. We don't know yet. These reactors that we work with are different, but they are all Generation 4. They all have a lot of safety advantages. To be honest, I'm not 100% sure, but as it looks today, I think we can have common rules across these and across the market segments.
Well, it all sounds quite exciting, so hopefully good things will come.
Yes.
Many thanks, Jan, for joining me today to discuss the role of nuclear propulsion across the shipping industry and clearing up some of the myths that are often associated with it.
Thank you.
Thanks again for listening to the LNG Industry Podcast. The podcast is available on all platforms, so subscribe for free wherever you prefer to listen. If you have enjoyed this episode, please rate and review and forward to a colleague or friend. Until next time.
LNG Industry serves as the go-to hub for all those following the latest developments in the LNG sector, providing spotlight interviews, in-depth articles, and regional report. LNG Industry covers the global marketplace. Register to receive a print or digital copy at lngindustry.com.